Okay, so in this video I'm going to talk about integration and the use of integration to find area. So integration can actually be used to find area. Can be used to find area under a graph. Alright, it can also be used to find the area between two graphs. It can also be used to find area between two graphs. Okay, for instance, you can be given, let's say we've got a graph like this, and then say this is the graph of g of x, and then there is another graph there, this one here. Say this is the graph of f of x, and then you want to find the area between these two graphs, which is that. Therefore, you just integrate. You find the integral of f of the graph of f of x. Dx, and then you subtract the lower graph, which is the graph of g of x, dx, and then you find the difference between the two is the area. Now, if you are looking for an area under a graph, for instance, you're given a graph of y equal to x plus 1, for instance, then you're looking for from this point to that point. This area can just be found by finding the integral of the graph of y, which is the integral of x plus 1 dx, like that. So the area under the graph there, from this point, say this point is A and this point is B, can actually be, so you're integrating y from A to B, which is that from A to B, like that. Now here, you need to take into account that if you're finding the area between the graph of f of x and the graph of g of x, you need to first of all find the points of intersection of the graph. So these points of intersection, let's give them the coordinates A and B. Now you're integrating within that region, so you're not integrating throughout, you're just integrating for the points between the points where the graphs intersect. So this will be integrated from A up to B, and this will be integrated from A up to B as well. So the difference between the because we said the integration gives you the area under a graph. So if you integrate there, you find the area under the graph, and then you subtract the area of the lower graph, and then the difference between the two will give you the shaded region there. Okay, so say for instance we've got to find the area between the graph of y, equal to y equal to minus x squared plus 8x minus 5, and y equal to x plus 1. What we have to do first is to find the points of intersection, i.e. the point where the graph y equal to y for the two graphs. So assuming this is y1 and y2, so the point where y1 in the first graph is equal to y2, which is the y for the second graph. So in essence, you're just equating the equations. So minus x squared plus 8x minus 5 should be equal to x plus 1. And then if you take everything on your left hand side, you're going to have minus x squared plus 8x minus x minus 5 minus 1 is all equal to 0. Therefore, minus x squared plus 7x minus 6 is equal to 0. Now, you can simplify this. This is a quadratic because you want to find the points of intersection. You can simplify this. Minus x squared plus 6x plus x minus 6 equal to 0, and then you factor out minus x there, x minus 6 plus x minus 6 over there equal to 0. Therefore, minus x plus 1 or x minus 6 equals 0. You're solving your quadratic there, and eventually you get x equal to 1 or 6. In essence, if we are to draw these graphs, if you are to draw these graphs, you're going to have a situation where you've got the graph of y equal to minus x squared plus 8x minus 5, and then you can also have the graph of this graph going like that, y equal to x plus 1, and then it intersects here at 1 there on the y. But the key thing here is that the points of intersection, that's what I want to show. This point is 1 and this other point is 6. So the point 1 and 6 relate to both graphs, and it relates to the point where the two graphs are intersecting. And when you are doing this, you are trying to find this region here, this common region here. That's what you're trying to do. So what we're going to do, we now have the points of intersection. Therefore, we are going to integrate. We're now going to integrate y1, which is minus x squared plus 8x minus 5 from 1 to 6 dx. We're integrating that, and then minus the integral of from 1 to 6 of x plus 1 dx. That's what we're going to do now. So we're going to integrate those two and find the difference. Now let's do the integration. Minus x squared to the power 2, when integrated it becomes minus x to the 3 over 3 plus 8x when integrated 8x to the power 2 over 2 minus 5x when minus 5 when integrated minus 5x to the power 1 over 1. Okay, now the limits, we're going to put the limits on there, 6 and 1, and we're going to substitute them in there later, but we are going to integrate the other part of the equation, and if we integrate x, it then becomes x squared over 2, and then plus 1 when integrated it becomes x to the power 1 over 1. So that's that, to the power 6. Well, the upper limit is 6 and the lower limit is 1. So the next step will be for us to substitute all these values in. Therefore, if we put in 6 there, you're going to have minus 6 to the power 3 over 3 plus 8 2, well, we're substituting with 6 there, 6, so you substitute 6 throughout, 6 to the power 2 over 2 minus 5, and then you substitute your 6 to the power 1 over 1. So that's the first part, and this part is subtracting. You substitute again, but now you're substituting with 1. So subtracting minus 1 cubed over 3 and then plus 8 1 squared over 2 minus 5 1 to the power 1 over 1. Okay, all this is in a box. You find the answer for that, and then minus. Now you go to this other part of the equation. You're substituting in brackets there 6 to the power 2 over 2, and then you're gonna do plus 6 to the power 1 over 1, and then so there's another bigger bracket to start with, minus in the other bracket, smaller bracket now, 1 over 2, 1 squared there, plus 1 squared over 1. Okay, and then you close there. 6 to the power 3, that's 6 to the power 3, it gives you 216, and then 216 divided by 3, it gives you 72. So 72, so that's minus 72. 36 times 8, that's 288 divided by 2, that's 144. And then 5 times 6, that's 13 divided by 1, that's 230, so minus 30. And then all these subtracting, just delete that. All this subtracting minus 1 over 3, and then 8 divided by 2, that's 4, plus 4, and then minus 5. All this is being subtracted there. And then on this other side, you're going to have 6 squared, that's 36 divided by 2, that's 18, plus 6, and then minus half, minus 1. Okay, so we're just going to simplify that now. Minus 72 plus 144 minus 30, that is going to give you 42. So this is in a bracket on its own, and then minus this part, and then 4 minus 5, that's minus 1, minus 3, minus 1 in the third. 1 in the third, then minus, so you're going to say 18 plus 6, that's 24, minus half, minus 1, that's 22.5. So your final answer is going to be 42 minus 1 and a third minus 22.5. So your final answer is equal to be 18.167 units. That's the area there. Okay, so basically that's how you can use integration to find the area under a curve or the area between two curves. Thank you for watching.